Hey guys, my name is Shreyas. Today we're going to be talking about binary covalent compounds. Now, before we do that, let's first discuss what nomenclature is. We've been talking about a lot of interesting things. Atoms, how atoms bring their subatomic particles together, how atoms come together to form compounds through bonding, but we don't understand one simple thing, and that's how do we name compounds? So that's basically what nomenclature is. It's how we name compounds. And the first type of compound we're going to be naming are binary covalent compounds. Let's first understand what a binary covalent compound is. A binary covalent compound is a compound which has two elements, hence the binary, which are to the right of the zigzag line on the periodic table. Okay. And I think that will make more sense as we do a few practice problems. And the way we name a binary covalent compound is we name the first element with the prefix, except for mono, and then we name the second element with the prefix and the IDE ending. So this probably makes no sense right now, but bear with me, because we're going to do a few practice problems, and this should start to lock in. But before we do that, let's first understand, this is what we need to memorize here, the prefixes. Make sure you memorize these. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. You need to memorize these prefixes. All right, so let's go ahead and do a few examples here so we go and understand how we actually do this. The first thing that we need to do in nomenclature, and this is a basic rule for all nomenclature, is that we ensure we understand the type of compound we're looking at. This video, we're talking about binary covalent compounds, and for binary covalent compounds have a specific set of rules. Other compounds, which are not binary covalent compounds, don't have the same rules. So whenever you're doing your nomenclature test, the first thing you need to make sure is that you identify the type of compound we're looking at even before you name it. So let's first ensure that all four of these are indeed binary covalent compounds before we name them with our binary covalent compound rules. Okay, so first thing is, let's make sure all these compounds have two elements, since the binary. So if you look here, all of these compounds have two elements. This one has sulfur and fluorine, this one has xenon and fluorine, this one has carbon and oxygen, this one has nitrogen and oxygen. So they are binary compounds. Now, let's make sure they're binary covalent compounds. And the way we do that is that we make sure all these elements are to the right side of the periodic table. So for our first compound here, sulfur and fluorine, both sulfur right here and fluorine are on the right side of the zigzag line of the periodic table. Okay, so sulfur, this compound right here, is a binary covalent compound. Let's look at our second compound here, xenon and fluorine. Xenon and fluorine are both to the right side of the zigzag line on the periodic table. All right, that's good. Carbon and oxygen are also to the right side of the periodic of the zigzag on the periodic table. So that's good. And nitrogen and oxygen are also on the right side of the periodic table. Nitrogen and oxygen. So we're good here. And by the way, all elements to the right side of the zigzag line on the periodic table are called nonmetals, in case you forgot that. So we've ensured that all of these elements here are indeed nonmetals, and all of these compounds have only two nonmetals. So we know for a fact that all of these compounds are binary covalent compounds. So it's important, whenever you get your nomenclature test, first thing you do is identify the type of compound we're looking at even before we name it. Okay, that's very important. So we know for a fact all of these are indeed binary covalent compounds, so we can go ahead and start to name them with our rules. Let's go ahead and look at our rules again here. So first, our rules are, we name the first element with the prefix except mono, which means what this except mono basically means is that if our first element, if there's only one of them, we're not going to say mono. And as we do a few examples, you'll probably get this. So name the first element with the prefix. Our element here is sulfur, and our prefix 2, so we're going to use the prefix di. So basically what we're going to write here is disulfur, for our first element. Now let's go ahead and tackle our second element here. Our rules say that for our second element, we name the second element with the prefix and the IDE ending. So we have 10 here, so we're going to write deca, because that's the prefix for 10. So deca, and then we're going to write the element, fluorine, but instead of writing fluorine, we're going to use the IDE ending. So instead of fluorine, we're going to write fluoride. Okay, fluoride, the IDE ending here. Okay, let's look at a few elements and think about what the IDE ending is. So for boron, that'd be boride, carbon, that'd be carbide, nitrogen, that'd be nitride, oxygen, oxide, fluorine, fluoride, phosphorus, phosphide, sulfur, sulfide, chlorine, chloride, bromine, bromide, iodine, iodide. Okay, everything else typically we're not going to see in binary covalent compounds, but that's basically what the IDE ending is. Instead of writing the element, we use the IDE ending. Okay, so we would say decafluoride. And this element, this compound right here is disulfur decafluoride, and we're done. Now, let's look at our second example here. We have xenon as our first element, and our rule says that we name the first element with prefix except mono. So we're not going to write monoxenon because there's only one. We're going to just write xenon. Okay, since there's only one. And this only applies for the first element within the compound. This is the first element, and there's only one, so we're not going to write monoxenon, we just write xenon. And then for our second element here, the rule says name the second element with prefix and the IDE ending. So our prefix for 6 is hexa, so hexa, and then write the element, fluorine, but then use the IDE ending, so fluoride. Okay, good. Third example here, we have carbon. We only have one carbon, so we're going to not say monocarbon because there's only one. We're just going to write carbon. And then for our second element here, which is oxygen, we have 2, so the prefix is di. And then we're going to write the element with the IDE ending, so the IDE ending for oxygen is oxide. Final example. We have nitrogen over here for our first element. Let's go ahead and name the first element with the prefix. So the prefix for 2 is di. So we're going to write di, nitrogen. All right. And then the second element is oxygen. Let's look back at our second rule here. Name the second element with the prefix. The prefix is 5. So is penta for 5. So you're going to write penta. And then we're going to write oxygen except with the IDE ending, so that's oxide. So dinitrogen pentaoxide. Now, this is wrong. And let me tell you why. Whenever we have oxides, which is basically an oxygen as the second element in a binary covalent compound, whenever we have oxides, and for some number of oxygens, we don't write pentaoxide. We just say pentoxide. Okay? We drop this vowel right here. We drop it. We don't say pentaoxide. This is only for oxide, so we don't say pentaoxide. We say pentoxide. And the same thing applies for some of these other prefixes. Listen to me carefully. We don't say monooxide, we just say monoxide. Dioxide and trioxide are okay, so that's okay. But then for these, we don't say tetraoxide, we say tetroxide. Not pentaoxide, we say pentoxide. Hexoxide, heptoxide, octoxide, non-oxide, decoxide. We don't say decaoxide or non-oxide, okay? I think a good way of remembering that is just that if the vowel here is A or O, we don't write that vowel. Okay, so this is a good example here. Since it's pentaoxide, we don't write pentaoxide, we write pentoxide. This is only for oxygen. I know these rules are kind of weird, and this is a lot to take in, so make sure you do the practice quiz that we have attached to this in order to master this concept. But that's it for now. Binary covalent compounds are as simple as that.